one, go. Hey, my name is Jan, and we are doing the pick and place robot.
My name is Salman.
And I'm Jake.
So in summary, our project is basically we are using camera image processing to pick and place cubes from one array to a different array. We started the project by interfacing the suction gripper using the HD-Link YML SM50, as shown in the picture in the top right. And the images were taken from our cell phones because the camera in the lab was not working. And we used image processing to locate all the cubes and to place them in a different array. And we will show you in depth more about our image processing process. Next. First, we started interfacing the suction gripper, as it shown in the red highlighted section. This is the circuit that we followed to interface the gripper with the robot and also with the digital I/O script that we used. Next.
Oh, my bad.
For image processing, what we used is raw images taken from our phones, and we used available tools from MATLAB to convert the raw images that were taken to black and white in grayscales, and to locate like the center of each mass, where the robot will locate them after doing like matrix manipulation to convert the image matrix into the workspace of the robot. Next.
All right, so I'm going to go a little bit more in depth on the image processing. The code on the left is what actually produces all of these images. So the first main one is going to be the image shown, and it's in gray because this line of code right here creates it to grayscale. That's going to be important later for the histogram as it reads the RGB values of each pixel. The next one is a display of the image on a coordinate system of pixels. As you can see, it moves from top to bottom and left to right, so it is going to be inverted in the end. Additionally, this will help us see where exactly each image is, or where each object is in relation to the origin. And then the histogram obviously gives us the RGB pixel values, and we can see where the color mostly lies to either cut out a certain part or make sure to include a certain part. So that's what we do in the next section of code. Pretty much everything over 140 is not used, and then the rest of it is black, which is what defines the top of our objects. And then the next step is we're going to create an outline of those objects to ensure that it's picking up the right objects, which is done in this code right here. And then if everything looks good from here, we can plot the centroids of all of these objects right here, which is shown in this plot. So that's what we're actually going to use to determine the location of the objects. So by doing measurements, we were able to determine that each pixel is 0.658 millimeters, which is going to be important to determine our first position. Additionally, we are able to gather the coordinates of each centroid, which were then converted to millimeters. With this, we were able to find the distance in the x direction and the distance in the y direction, and subtract and then divide or add them up and divide by 6 to determine the average value, the average x value in between all the blocks and the average y value in between all the blocks. So that's what's shown right here. And then to determine our position where we're going to pick up the first block, we took the centroid number 7, which is going to be this block down here, because it's actually our first block. Or sorry, it's this one right here, because it's inverted from the image before. And we add that to the robot's initial position, and then that will give us this first position for the object, which is shown right here. This is just the location settings for where we're going to pick up that first object. And then the average X and Y are implemented into the variables. X is going to be the layer thickness, and then Y is going to be the level thickness. And then the main source, or the main code for our robot is here. So first it's going to pick up a block, and then every time it does, it's going to move through and keep picking up a block. If it reaches its max amount of layers, which is 3 because it's a 3x3 matrix, then it's going to move over to the next level, and then it's going to repeat that same process. And then once each of them reaches the max layer of 3, it's going to end and reset. And the same thing is happening for the place program, except rather than moving in the X and Y direction, it's going to stack each block 3 times and then move over. And that's what's shown in this one. So as you can see, for picking up, we have it in the X and Y directions. And then in the placing, we have it in the X and Z directions.
All right, so here are a few photos of us working on our project. We had to accurately measure the distance between the blocks, between the different columns of the matrix. And in order for this to be successful, the spaces in between the blocks had to be equal. Next slide. And we implemented the project at different speeds to determine its accuracy. And you can see here, this is at low speed, and it's going to pick from that 3x3 matrix and stack them up in a different 3x3 matrix. As you can see, at low speeds, the accuracy is a little bit better. We can compare like the new matrix at low speed to the new matrix at high speeds. So as we can see here, at high speeds, the robot doesn't place the blocks exactly at the same spot every time. And so it causes like some displacement of the blocks as they stack up against each other. All right, so a few things we learned while completing this project was how to use computer vision for the determination of locations of objects. This project increased our knowledge of ACE programming because we're able to create loops and using if statements for picking and placing in arrays. We learned more about digital I/O systems, and overall, we learned how to use a SCARA robot. Thank you.